All right, welcome everyone. Now we have another talk on open source developer Adrin, and he's going to walk us through Pickle, which is one of the scikit-learn libraries, and he's also going to talk about his experience working as an open source developer. Enjoy the talk.
Hello. Nice to see you now here. We're going to talk about having a little bit of fun with Pickle and how we realized like a long time ago that there are certain things that are not ideal, what we could do about it, and what we did or what we have done so far. I'm Adrin. I did my academic life was in bioinformatics. After that, I didn't want to work for big pharma, so I went into machine learning consulting, left the bio side behind, did a bunch of stuff, then ended up working on scikit-learn. I woke up one day asking if I want to be a core dev. I was like, hell yeah, why not? And then since then, I've been working on also Fälle and skops. So we're going to talk about Pickle and things that you don't necessarily want to happen, but it could happen when you load Pickle files. Let's see. I'm going to import Pickle, and then I'm going to load this byte string. Probably by looking at the byte string, you can imagine what it already does. Is it large enough, or do you want it larger? People in the back. Bit larger. Okay. When I run this, it prints hello world and it returns 0. So you can already see there's a side effect here. I just loaded something. It did return 0. So like what you usually do is that you put that in a variable and you go on with your life, but you would not expect that side effect. And it's not even printing something. It's doing system.echo, so even worse. How does it work? Well, this relies on OS being available when you're loading Pickle. Kind of clearly here it's doing os.system and then echoing. And then you could be like, if you know Pickle well, you could be like, well, I could actually tackle that. I could have my own unpickler. And then I'm going to go be like, there are certain things that I allow, and then there are certain things that I don't allow, and then I'm fine. Well, yeah, maybe it does fix some issues, definitely. But there is this, my favorite thing is this one, which exactly says, well, you wanted to do that, now let's do an exploit. And you create a custom Pickle that changes the global variables that you were using in your restricted unpickler, and then you can, again, load whatever you want. It's a really nice read. I definitely recommend you going through this. So this was the state, and then when you look at the Pickle documentation in Python, it definitely says, do not unpickle data received from an untrusted or unauthenticated source. People used to do things like, well, I want to like have some safe constructors or safe for unpickling back in the day. But since Python 2.3, so a long time ago, they removed that. They were like, no, there are actually exploits against those. And me being in the scikit-learn world, we want people to be able to dump their models and share their models. So how do we do that? Before getting there, let's talk a little bit about some of the machineries of the Pickle. We have the pickler, and then you have the unpickler. So what we did above here was that we would have a custom unpickler with a find class that we overwrite there. And then you have a bunch of instruction set opcodes that are in your Pickle file. And basically, when you load Pickle, you're running code that as the result of running that code, some data is constructed, and you get the result of that, which means you're running code. So like not all of that code has to be exactly for the purpose of constructing the object that you want to return. How does Pickle work? How does Pickle know how to pickle an object, a Python object? When you have a very, very simple Python object, like imagine you don't have any fancy new, dunder new defined, it's just like an init constructor. You have a bunch of things in your class. What it uses are get state and set state. Most people wouldn't override these, but you could if you wanted to. So let's play around with these a little bit. Here, I'm going to have a class C. It doesn't have anything in it, but in its get state, I'm going to return a dictionary, and in its set state, I will get that state, and then I will go through that dictionary, and I will set attribute on self, whatever is in that dictionary. And then if I do pickle load of the dumped version of C, I will have this A available. So I don't have anything in my C, but with get state and set state, I could have some side effect. Now you can imagine you can do a lot more in these like get states and set states. There's this really nice pickle tools in the standard library, which has a disassembler. And then you can look at the dumped version, and it kind of gives you an idea of what would happen if you were to unpickle this data. And here you can see, well, there's a class C, there is this like attribute A, this like 42. Not very readable if you're not familiar with it, but like you kind of get an idea. And then does it work if I pickle and try to unpickle this thing? Well, it does. I got my object C. But what if I try to load that same file in a different Python process? How would this work? Any ideas? Would it work? Would it not work? I do get the error that attribute like C is not a part of main. Because here, as you saw, it is trying to basically import C from main. And if you don't have it, then it doesn't work. That's why you have Cloud Pickle that can also like pickle like code, like custom code and all of that, which makes things even less secure. So okay, I need to at least have them somewhere installed. But I can have more fun. The next very crucial component is this reduce. This is where things get really interesting. Reduce returns a tuple of up to size 6. The first two are mandatory. The first one is a callable that would construct the object for you, and it would kind of return like usually an empty object, but if it's not empty, then the second tuple that reduce returns would be the arguments to that constructor. So if you have a new, then, and your new takes like a bunch of like custom arguments, then like you can like return those arguments here, and then Pickle knows how to deal with it. Okay, sounds pretty useful, but I could have more fun here. I can implement reduce, and I can return as my constructor print and the arguments to that print. And then when I look at the disassembled version of this, well, I'm doing print built-ins, I pass it something. There is no trace of this D. Because Pickle was like, okay, I call reduce, and that's your constructor. That's what I'm going to use. So I tried to dump D. What I got has nothing to do with D. And then when I load it, it just prints. I could have even more fun. Well, my constructor could be os.system, and then now I can echo something in a file. And here, for example, I have only this one pickle. I run this, I look at it, you can see that like from POSIX system, it calls echo, and then I still don't have that file, but if I try to load it, it returns 0. It looks very innocent, but now I have a file here. You could do, of course, a lot worse. Like while loading, you could connect to a remote server and upload all users' private keys and everything to your remote server. And you wouldn't even realize that that happened. And if you have a host that is like doing somewhere on the web like a lot of stuff, you can just like load your pickle, and like in their system you would have like all the privileges there. So it's really bad. And you could easily construct that pickle. Like we didn't even go into how do you construct a custom pickle file. No, like it's like all in Python. If you want to construct a custom pickle file, then it can get a lot worse. My favorite thing is that there are some opcodes like DUP that duplicates the top of the stack that is never produced by the pickler, but it is in the opcode, and unpickler understands it. So you can do things like damaging like the stack, or like making your Python just like do a core dump. It's fun. We could, any questions up until this point? I'm happy, like, shoot any questions in the middle of the talk, please. Good. We can, as I said, loading a pickle is basically running code. So maybe I could look at the code, and that would make it a little bit safer. Before I run code, I look at that code. There is this nice library called Pickling. And it can give you the code, and then you can like use ASC to get the abstract syntax tree to see the code that would have been run if you wanted to load something. Here, I just want to load a list, 1, 2, 3, 4. If I print that, then this would be the code that is running. Makes sense. I have a bunch of constants, then I have like a list, and then like I'm returning that. What if this E object that I had, I do the same thing with that object. Here, I can see that, oh yeah, like from POSIX, there's some variable, it's calling this echo thing. Okay, it looks fishy, and then it's returning something that is like completely empty. It also, it gives you a CLI command that you can just look at your pickle, and it would give you the equivalent Python code that would result in what it's returning. Makes sense. It's in C. I was actually doing like set state with this dictionary. It returns that. Sounds pretty nice. I do the same with the other file. I very clearly see that it's like running system. But what if, like, when I was going through this whole path, I was like, oh, this sounds good. Like, I should be showing my users what's the code that is running to, like, when they load their pickles, and then they can make a very informed decision. And then very soon I realized if I do anything more meaningful, like actually meaningful, like a very simple logistic regression, let's look at the code of that. It's not even in a pipeline or anything, then this would be the code. Then I realized if I'm asking my users to understand this before loading any pickle, then it's the equivalent of me asking users to understand those TOCs before clicking yes, I agree. I'm not going to go through that. There is this, the Pickling library is also here, really nice. There's also like a corresponding blog post. Definitely recommend you go through that. So this was when this was the story, and like a lot of people who were aware of the security issues, we knew it's this bad. But we didn't necessarily have a solution, and a lot of us also thought like there is no solution, there cannot be any solution. And in one of the conferences, we had a discussion, and I was like, well, I'll give it a shot. And that's what I did for the next couple of months, and that's what resulted in skops. Before we go there, any questions up until this point? Cool. So, being one of the scikit-learn maintainers, I had a little bit of insight on what scikit-learn does, so it made it a little bit easier for me to dig into it, but I also had to go read a little bit of CPython code, which was really fun. And then we were like, okay, like we have the same API, skops.io, you load and dump like Pickle. With the difference that if you actually try to do that, it raises an error and it says like, I can't load this, I don't know this class. It is the same as, so when you look at the machinery, it's the same as Pickle trying to do the same thing with a little bit of a difference, that when I am loading Pickle, I'm running code. Here, when I raise this error, I have not run any code other than reading a JSON file. We'll get into that. So if you can exploit the JSON reader, sure, there are those exploits. Otherwise, I'm not running any code before I raise this exception. And then the user has to explicitly say, I trust like these objects. Or if you really, really trust the file, which should only happen if you're loading a file that you yourself created, then you can be like, yeah, I trust everything. So what does this work? What did we do? Let's look at some of the files. So let's dump this D and C and look at the files there. It's a zip file with a JSON schema, and it says I have D from main. There's nothing in it. Pretty much that. Okay, easy. And then if I look at this C, I don't know. Why did the other one open it there, but this one here? Okay. It's a little bit more. I have this like 42, everything that is JSON serializable is just in this JSON file. Okay, pretty innocent looking. And then if I, ooh, what happened? Huh, I lost my browser. That's what happened. Sorry for the hiccup. Yeah. And if I look at this scikit-learn model, how am I? Was it here? Yes. What am I persisting there? This logistic regression model. There's a little bit more. Sure, I have this file, the same thing. It has all the attributes, except that some of those attributes are NumPy arrays. And whenever I encounter a NumPy array, I just save it with NumPy format. So pretty easy, really. And what we use there, like under the hood, is numpy.save. With an asterisk that by default, when you do numpy.save, because it's supposed to work on everything that you have in your numpy array, it allows pickle. If you have a numpy array with the D-type object, it actually pickles everything. It is not the numpy format. And if you say allow pickle false and your D-type is object, it would just fail. And what we do is that if the D-type is object, then we try to persist it the way that we persist objects. And then when we load it, by default, allow pickle is false. That's sensible. And we also say like, yeah, allow pickle false. That's how we load it. That's how we make sure like we're not using any pickle there. And that's why this works. So the format it's basically a zip file. You have that JSON schema, which can be pretty large. And then we have those NumPy formats. Inside, we also have a bunch of custom, there are a lot of constraints there. The reason that this, to me, is a little bit safer than Pickle is that we don't support everything, and we don't call any random new or any random thing that the reduce would return. For most cases, we don't even call reduce, which means that's why when you looked at the dumped version of, we had it here, D, when you pickle D, you don't have a trace of D because reduce was returning something else, but here I'm loading actually D because I don't even call reduce. So the assumptions we make is that your object has a default new or a new that takes no arguments. If you have a custom object that takes some arguments in new, then this wouldn't work. Or we would have to add something in the skops library for that to work for now. And we are like get state and set state should return everything, which is, again, in most cases, quite okay. Even so now we support GBM and XGBoost, and the way it works is that get state returns a byte array, and set state uses that to construct the binary object that is the tree that you have down there. We have some custom code for a bunch of types like dict, set, list, tuple, type, slice, or partial, or a bunch of like scipy and numpy ufuncs, or like RNGs, random number generators. There are some C extension types that we have custom code for that are in scikit-learn. That's why if there is some library out there that has also another like random C extension type, there needs to be some code here. For now, in future, in our roadmap, is that for us to make that a little bit more extendable. And those objects are hard-coded there. And then it's some other code for scikit-learn's custom objects. Again, this is not supposed to be able to persist everything. That was not our scope. If we wanted to have that as the scope, then we would be reinventing Pickle. And then the way that we load is that we load that JSON schema, and then we know what we are going to load, and then we look at this schema before loading anything, and we tell the user, hey, like you're going to load these things, we don't trust it, do you trust them? And then we load everything. And then we call new and set state on those objects. There is an online app where you can go, and if you have the latest, if you have a file that is persisted using the latest version of scikit-learn, you can try to convert that to the skops format without like trying to run that on your machine if you want, or if you don't want to do that. And then if it fails, please let us know, open an issue. Is it really safe? No code is 100% safe, really. But we are trying to make it a little bit safer. There are some vulnerabilities, like if there is any zip vulnerability, then sure, we have it. We are unzipping something. If there is any JSON vulnerability, then yes, we are loading a JSON file. You have things like zip bomb that like loading a zip file would construct a massively large object or try to do that, and then you would get out of memory error. So those issues do exist. Again, we don't support custom objects. We want to make it a little bit more extendable, but we need some help from you. And that is to test it, break it, and let us know when it breaks. Thank you.